Good morning, everyone. Okay, let's get started. In the last lecture, we were talking about how we could think of the total displacement for a particle, right? And here is where we stop. I, I told you about 37 degrees, right? Okay, so let's start with that. Okay, so if you've got a triangle, if you've got a right angle triangle, maybe this way, right? Okay, and opposite side of this angle is 3 and the adjacent is 4, and this is a right angle triangle, so this will be 5, right? So for such a triangle, this angle will be 37 degrees because just like you do remember different values, this is one more value that you are required to remember. Sine 37 is very close to 3 by 5. Cos 37 degrees is very close to 4 by 5, and that means tan 37 degrees is very close to 3 by 4. Okay, so these are three values that I would ask you to remember. Okay, and of course along with it you would have it this way as well, sine 53 degrees, because this angle and this angle are complementary, so sine 53 degrees will be 4 by 5, right? Okay, cos 53 degrees will be 3 by 5. This is based on rules for complementary numbers, complementary angles, right? And similarly tan 53 degrees will be 4 by 3. Okay, so these are some additional values that you have to remember. Okay, we use these values often in physics problems, right? Okay, now let's continue with what we were talking about, right? So here it's that we calculated the displacement of this person, right? Going here, going there, right? And this is what we got. Again, just to remind everyone that displacement is a vector, right? Displacement is a vector. It has a magnitude. It should also have a direction, right? Okay. So now on to the triangle law. Now you might be wondering, why did I mention all this in triangle law, right? Okay, Gracie, yes, we are coming to what you asked, right? This topic is still how to add vectors, right? That is triangle law of addition. So the basic idea that I've taught you so far is as follows. If some person, let's say, moves from this point origin to some point A, okay, and then from there moves to B, right? Let's say from O to A and then moves to B. Everyone, listen to this carefully. In the part 1, the displacement of that person is from O to A, right? So that you could indicate by a vector from O to A like this. Again, everyone, it is that in the first part the displacement is from O to A, right? Okay, maybe 30 meter. And let's say in the second part the displacement is from A to B, right? So that is drawn as an arrow from A to B. Clear? Right? So there are two displacements, one from O to A and one from A to B. Again, displacement is a vector. That's why I'm drawing these arrows, right? Let's say this is 40 meter, suppose. Let's say that this is 40 meter. So now if I want to find the total displacement, total means addition, I hope you realize that. If I want to find the total displacement, then it is natural to take the displacement of part 1 and add it with the displacement of part 2, right? But I hope you realize that the total displacement that is from O to B, the total displacement that is from O to B is actually in this way, right? Correct? Right? I hope all of you understood that. So this is exactly what the triangle law of addition is. This is exactly what the triangle law of addition is. How? Well, have a look. Have a look at the drawing that has come out on its own, right? When I've drawn the displacement in part 1, okay, here one side of triangle, then I've drawn the displacement in part 2, okay, another side of triangle, and then when I draw the total displacement, then I'm getting the third side of the triangle, right? So that's why this is called the triangle law, right? So again, to clarify, if you think of the vector OA and with that you add the vector AB, then you are actually getting the vector OB. Is this clear, everybody? Adding one displacement with the second one gives us total displacement. See, everyone, it is important to understand why we have this law, and that's what I'm trying to do. That's what I'm trying to explain. Otherwise, if I wished, I would have directly made you write the steps of the law, okay? And then you might never get the answer to why do we make a law like this. It will not be 70, Divya. It will not be 70, everyone. Okay. Right? Again, I want all of you, see, whatever I say, it's going to be extremely crucial for the next 1 week or so, right? It's going to be extremely crucial. If you have any minor doubt, you should definitely ask. If you don't ask, then it's going to be a lot of trouble later on. Chintan, no, don't try to mix such things, right? This has nothing to do with Pythagoras theorem, everyone. What I have written so far has nothing to do with Pythagoras theorem. Okay? Follow. What is essential? What is essential is you understand that if you want to add two vectors, you have to make a triangle like this, right? So I said that if you take a displacement 30 meter like this, and you take another displacement 40 meter like this, then the total displacement is from here to there, right? So it's making a triangle. That's what I'm trying to teach you. So now it's about the triangle law. Okay, so here is the exact law or steps for triangle law. Okay, right, let's see. So step 1, draw. Okay, we are just going to assume that we want to find, or we want to add a vector plus b vector. Okay, so if we want to draw a vector plus b vector, okay, so this is what we want to do, right? If we want to draw a vector plus b vector, how would we do it? Okay, how would we add them, right? How would we perform this addition? Let's start. So the steps are as follows. Number 1, draw the first vector that is a, right? Draw the first vector that is vector a. Okay, right? Then second step, from the head of first vector, that is from the head of vector a, draw the second vector. So which is the second vector? B, of course, right? The second vector is b. Okay, so what are these two steps? Let's draw these so you will understand better. Okay, I hope everyone has written the two steps. There are more to come. Okay, it's not over yet. There are more steps to come. First one, so we will draw vector a. Let's say vector a is in this direction. In what direction it is and how it is situated, that will all depend on the question. Here we are just trying to practice how to do a vector plus b vector. All right, suppose a vector is any random vector, anything, maybe like this. Okay, and if we want to find a vector plus b vector, how would we do it, right? I'm describing the procedure, right? Okay, so that's a vector. Now what does it say? From the head of first vector. Okay, so this is the first vector, a vector. I hope everyone realizes that this point is called tail of the vector, right? And this point is called head of the vector. Okay, right? I hope nobody has any kind of confusion with head or tail. All right. Okay, so let's continue. There was just a problem with the internet connection. It just dropped off and started again. I hope all of you can hear me. Okay, so let's continue. Are you all there? Can you hear me, everyone? Can you hear me? Yeah. All right, all right, all right. Yeah, it looks like you can hear me. So I said that this is a vector a, and this is its tail, and that is the head, right? That is the head. Now follow the step 2. What's the step 2? From the head of first vector, that is vector a, draw the second vector. So from here, from this point, I will draw the vector b. So like let's say vector b is in maybe in this direction. Okay, again I'm just giving you an example. Please don't ask me how do I know vector b is in this direction. I don't know. I'm just giving you an example that will make the process of adding clear. Okay, right? So this is vector a and vector b drawn. Okay, Now step 2 is complete. So let's talk about the third step. Let's talk about the third step. Step 3. Draw a vector from tail of first vector to head of the last vector. Okay. Why am I writing first and last? You will know that later. Okay. Right now you just write it as I am saying. Over the time you will understand what is the importance of writing first and last. Why didn't I write first and second? Okay. So what have we said here? We say draw a vector from tail of the first vector, right, to the head of the last vector. So of course here the first vector is A and we have drawn only 2, so this is last vector. Agreed? So from the tail of first vector to the head of last vector, we have to draw a vector, right? From the tail of first vector to the head of last vector, we draw one more vector. All right? Okay. And now it's time to name it. It's time to name it. Okay. This vector, okay, the one that you have drawn now, this vector is A vector plus B vector. Okay. This vector is A vector plus B vector, and generally when we add 2 or more vectors, we say that the answer or the total is a R vector. R stands for resultant vector. See, it's capital R, everybody. Okay, not small r. Small r stands for position. This is position, right? Okay, so capital R stands for resultant vector, right? And resultant means addition. Everyone, it's not difficult. Resultant only means addition, right? That's it. So where is A vector plus B vector here in this triangle? Well, here it is. I hope this is clear, right? You can clearly see this is making a triangle, and hence the name triangle law of addition, right? I hope it has been easy for you to understand how it's making a triangle and what's the exact procedure, right? You have to follow this procedure. See, everyone, you have to follow this very procedure, right? Okay. So that's the triangle law of addition. Now if you will just go back and see what we have been talking about, it will make a lot of sense. Earlier we did it as follows, that if someone would start from here, have this displacement O to A, right, and then from A to B, right, then we said that the total displacement is like this. See, which is the first one? This is the first one, and this is the last one, right? So from the tail of first to the head of last. So this is the vector OA vector plus OB vector, right? So that's why I'm saying this is total displacement. That's why this is the total displacement. So it's not a surprise actually. Listen to this carefully. The law was written, the law was made, the rule was made like this only because displacement adds like this. Everybody, this rule was made just like this because displacement adds in this way. Okay, આ લો સ્પેશિયલી ડિસ્પ્લેસમેન્ટ ને ધ્યાનમાં રાખીને જ બનાવ્યો છે. I hope you understand that. Okay, so we understood that whenever there are vectors, they must have this kind of property. Whenever there are vectors, they must have this kind of property so that they will follow triangle law of addition. So please remember that every vector must follow this law. Every vector must follow this law of addition, right? Whenever you add two vectors, it can be done or must follow this law. Okay, so that's about the triangle law of addition. Very quickly, I will tell you something, a word of warning, that is, suppose this is a vector A. It is not OR, it is OB. Suppose this is a vector A and this is a vector B. And let's say you join them like this. Then this is not vector A plus vector B. This is nonsense. Why? What's the problem? Look at this. Have I drawn the second vector from the head of the first vector? No. You have to be very careful, everyone. I hope you realize that this does not follow step 2. This diagram does not follow step 2. Yes or no? Okay, so then if you make a triangle and say, sir, I got addition vector, then this is wrong. This is not addition vector, it's actually something else, right? Yes, Divya, you are right. If you do it that way, A vector will be its result. Anyways, we'll talk about that later, right? So this is enough of warning at the moment. Don't do it like this. Okay, so now that's the triangle law of addition of vectors. Let's go to the next law. Triangle law of subtraction. Okay, so that is, if you want to add vectors, you have to make a triangle. You have to draw a triangle, and then that gives you the addition vector. If you want to make a subtraction of vectors, if you want to subtract vectors, then once again you have to make a triangle, right? But the procedure is quite different. Listen to this carefully. It can be confusing. I'm warning you at start. Pay attention. Procedure is different from the triangle law of addition. Okay, procedure is going to be different. So let's see how this procedure works. Again, first of all, I'm going to build your idea about it. Why do we have such a triangle law? Let's talk about that. Why do we have such a triangle law of subtraction? Once again, we are going to talk about displacement, because the truth is that all of this, all the drama about vectors actually originates in displacement, right? When people realize that displacement is a vector, and then displacement is a vector, so velocity is a vector, so acceleration is a vector, so force is a vector, so many things are vectors, and then suddenly we need to develop a separate branch of maths which deals with only vectors, nothing else. Okay, so let's see. Suppose this terrorist that we have been talking about was here, let's say. Okay, and now that terrorist roams around here and there. Okay, and finally reaches this point. Okay, right, so finally the terrorist reaches that point. All right, so I am absolutely sure that you agree that this point A should be called initial position. Oh, sorry. This point A should be called initial position, and suppose this point is B, then that point B should be called final position, right? Okay. Here is origin. So first of all, I am going to draw the position vector. Okay. Again, what is a position vector? It's a vector drawn from origin to that point, or to the point where object or body is located, right? I hope you remember this, right? I mentioned it yesterday. So let's draw the initial position vector. Okay, we are going to draw the initial position vector. Now that you have understood how this person moves, right, in a weird path again, right? Let's say the path of that person from here is not straight, maybe like this, right? Roaming in the forest. Okay, so let's draw the initial position vector. This is initial position point. Is this clear, everyone? Is this arrow clear? R1 vector. R1 vector stands for initial position. Is this arrow clear, everyone? Okay, very good. Right, fine. Is it that only 10 of you have understood? Then I think I should repeat. Not even 10. We are in single digit here. Are you sure? Others not clear? If it's not clear, please tell me. એવો કોઈ વહેમ ન રાખતા કે અત્યારે નથી આવડ્યું પછી આવડી જશે. એ પછી ક્યારેય નહીં આવે ફિઝિક્સમાં. So please respond, everyone. Okay, that makes me think like I'm not teaching a laptop. Okay, I hope there are humans on the other end. So again, what is a position vector? You draw from origin, from here to the point where object is located. So we draw an arrow. That's why this is a position vector, right? This is not a graph, Kunal. Please don't look at the screen. Listen to what I'm saying. Audio is very important. I said that there is a person here, that person walks off like this and goes to this point. This is not a graph. Okay, this is an actual person, who moved from here to there, right? Okay, so now here is the point B, right? So that's where the person is. So now it's time to draw final position vector. Can you tell me how I should be drawing final position vector? From which point to which point? I should be drawing final position vector from which point to which point? Final position vector from which point to which point? Very good, Priyansh. No follow-up. Okay, the correct answer is the final position vector is drawn from, dear friends, please read this. Drawn from origin to the point where object is located. So here is the object at B. So I should be drawing the final position vector like this. Clear? So I hope those who said A to B, this is understood now. Okay, right, fine, fine. So it's time to go to the next thing. Listen to this very carefully. If I would ask you, if I would ask you that if you just ignore vectors for the time being, okay, ignore vectors, right? Let me just erase it. I hope you have understood these vectors, but let me just erase those vectors, all right? Okay, we will draw it again, no problem. We will draw it again. Okay, right. Let's keep it simple. Okay, this guy walks from A to B, right? Can you draw its displacement vector? Can you draw this person's displacement? Where would the person's displacement be? Position vector tells you about position. Simple, Sahil. This is not about according to law of addition, Ayushi. I'm just asking you, forget about vectors. Where is the displacement of this particular person? It is from A to B. Yes, very good. So many of you identified it correctly that the displacement is from A to B. So do you realize that this displacement does not depend on path and it should be a straight arrow like this? Is this clear? Is this clear that this is displacement? Yes or no? Again, that's because displacement does not depend on path, right? It only depends on initial and final position. Again, this is where photo method helps wonderfully. Photo method, right? પેલા A ઉપર જોયો તો બરાબર, ઓકે, ટેરરિસ્ટ સ્પોટેડ, પછી થોડીક વાર આંખ બંધ કરી દીધી. Okay, now eyes open, terrorist spotted again at B, right? So the displacement of that terrorist is from A to B, right? As simple as that. વચ્ચે ક્યાં ગયો તો એનાથી હવે કઈ ફરક નથી પડતો, right? So that's the photo method. Fine. So I think it's really essential for all of you to understand that the displacement is from A to B, an arrow like this, correct? A vector like this. Now, let me draw those two vectors again. Okay, let me draw those two vectors again, which I had just erased. Oh. So this is R1 vector, which is initial position vector. This is R2 vector, which is final position vector. Okay. And tada, we have a triangle again, right? We are seeing a triangle, aren't we? Right? Okay. So how does this work? Let's see. Everyone, I'm sure you know this formula. જો આ ફોર્મ્યુલા ન આવડતી હોય તો ખરેખર બહુ મહેનત કરવાની જરૂર છે. I'm sure all of you know this formula. Right? And this is nothing but displacement formula, right? This is displacement vector. Okay. So do you see we are subtracting here? Right? We are subtracting. Right? And when we subtract and we get the answer, so we draw this, and when we draw this, we get a triangle. Have a look. હવે આ ભૂલી જાઓ. Yes or no? I repeat, we are subtracting this and this, and so when we draw all the three vectors, we are getting a triangle. જો મેં હજી તમને લો શીખવાડ્યો નથી હો, તોય તમે ટ્રાયંગલ સમજી ગયા ને. I'm sure you realize that this is coming on its own, right? I have not taught you the law of subtraction yet, correct? So at the end of this class, I will tell you a very important lesson. જે બાયોલોજી વાળાને બહુ ગમશે અને મેથ્સ વાળાને એવું થશે કે હા બરાબર છે. ઓકે, રાઈટ. સો ફલક just said અંદરથી આવે છે. How many of you agree with him? ફલક said અંદરથી જ આવે છે. How many of you agree with him? તો જેને અંદરથી આવ્યું એને ફિઝિક્સ સમજાણું. ઓકે, right. Okay, fine. So you see, this is the triangle that we are forming here. So let's look at the procedure. How did we subtract actually? Think about this. Okay, first we know this is initial position vector. First we know, and then we know this is final position vector, right? And now if you want to subtract them, let's say I want to find where is this vector. Okay, where is this vector, right? I want to draw this vector. So how I'll do it is I'll take one head and another head and join them and put an arrow like this, correct? I repeat, I will join one head with the other head and I'll put an arrow on one side. On which side? On the final side. Do you see? On the final side, right? Correct? I'll put this arrow not here, that would be wrong. I'll put the arrow on the final side. Clear? And when I do that, I will get the delta r vector, right? I hope everyone notices that. So let's write down the steps. Let's write down the steps of triangle law of subtraction. So here we go. Steps for triangle law of subtraction. Right. Ola જેમ જ steps say we will draw diagram also, right? So step 1, draw both vectors with common tail or same tail. Okay, what is the meaning of this sentence? How should you look in? Sorry. Well, this is what it means. Suppose this is vector A and this is vector B. Okay, is this point necessarily origin? No, not necessary. Any point, okay, but common tail, that's it. Okay, it can be any point, but it has to be common tail, right? From a common point. Yes, you could say that. Draw both the vectors with same tail or from common point, as you want to write. Okay, આ બધું લખવાનું important ખાલી તમારા માટે જ છે. What is more important is, can you actually use this rule? Okay, that's it. ગોખીને ગયા હોય, સ્કૂટર લેફ્ટ સાઈડમાં ચલાવાય, રોંગ સાઈડમાં ન ચલાવાય, બરાબર ને? પણ ફોલો ન કરતા હોય તો શું કામનું? ખબર ન પડે કે લેફ્ટમાં ક્યારે ચલાવાય ને રાઈટમાં ક્યારે ચલાવાય, ક્યાં ચલાવાય. હા, તો જેમ એ થાય તો એક્સિડન્ટ થઈ જાય, right? I hope you understand that if you don't follow the procedure properly, there will be accident. Just like that, here also there will be accident, right? In both situations, you will be badly hurt. You will not like the result in either case. Okay, so step 2. Step 2, join, no sorry, draw a vector from head of B to head of B vector to head of A vector. See, this is important. From where to where? From head of B. Okay, so we start from here. All right, we will start from here. To where? To where? To head of A. So till this point. Clear? To the head of A. So we have to draw a vector from head of B to the head of A, right? So shoot it like this. Think of vector like a harpoon. It will help. I hope you remember what is harpoon, right? From B to A, right? We could draw from A to B. Ayush, we will do it later. Okay, just hold on that thought. Right now we are doing something else. You follow it exactly as I'm saying, everybody. You don't have liberty. Okay? See, this is just like if this is a road and you are supposed to go over here, then you should be driving on the left if you are in India, right? Okay? તો પછી તમે એવું કહો તો ન ચાલે ને સર થોડુંક આમ જઈ અને પછી આપણે આમ જશું. That is not valid. થોડું કઈ નહીં. You don't have any kind of liberty when you follow this law. You have to follow it exactly, right? So let's name it now. What is this that we have drawn, right? We have drawn something, but what is it? This vector is A vector minus B vector. What you have drawn is A vector minus B vector. Okay, so what we have drawn here, this white one, is the A vector minus B vector. Clear? Okay. A very easy way to remember is like this. This represents final and this represents initial. I hope that it is clear. So you should go from initial to final, not final to initial, right? Everyone or anything always goes from initial to final. Do you agree with this idea? Right? Okay, I used to also make people remember it like this. H minus T. Head pehla આવે ને. H is first in alphabet, isn't it? Right? So head is at A and tail is at B. Have a look. Have a look at this vector. Where is its head? Head is at where A is, and tail is where B is. Clear? Okay. So that is how you find or draw A vector minus B vector, right? Clear? Now see, suppose you want to draw the other way. Let's look at this very carefully, everyone. Okay, suppose this is A vector and this is B vector, drawn with common tail or the same point or from the same point, right? And now I'm giving you two choices or two possibilities. Let's talk about two possibilities. Sorry, just a minute. અરે શું થાય છે? Something is wrong here. Just give me a minute. I'll just clarify. Yeah. Okay. So if we draw it like this, right? That's option 1. Okay. And if we draw it opposite like this, that's option 2. So can you tell me what is the vector 1? Can you identify or can you name this thing? What is this vector 1? What is this vector 1? It is displacement m nahi. Look at this. We have followed the triangle law of subtraction, right? Yes. So vector 1 is a vector minus b vector. Okay. Vector 1 is a vector minus b vector. Okay. Right. And what is the vector 2? Think about that. I want all of you to think about what is the vector 2. Think about what is the vector 2. Very good. Displacement નથી જોતો answer, Gracie. No, Dharmi, it cannot be addition. No, Ankita, wrong. Hard, no, wrong. It is not addition vector. We are not following rules of addition. No, it's not R. Yes, the correct answer, people, is B vector minus A vector. This is the correct answer. Right? This is B vector minus A vector. Where head is located, that is final, not initial. Where head is located, that is final. Here is the head, so that's final, right? So it is always final minus initial, isn't it? It is always final minus initial, right? So this is B vector minus A vector. Just like that, here the head is located at A, so this is final minus initial. See, some of you said that this is A vector plus B vector. Let me clarify why it cannot be like that. Okay, why it is not like this? We are not following step 2. What is step 2 for addition? What is step 2 for addition? Everyone read that step. આટલી મહેનત કરીને લખાયું છે. Please read that step, everyone. What is the step 2? Please read it. Okay, everyone, please read it. Does this follow second step of addition? Does this diagram follow second step of addition? Right? So that's why this cannot be, addition, right? No way. There is no way that this is addition, right? I hope that is clear, right? This is B vector minus A vector. All right, so this is how you find it. Clear? This is how you find it. Yes. No, yeah, you could say that. Ayush, you could say that. But first thing is, we have drawn the two vectors with common tail. We have drawn the two vectors with common tail, right? So that's not what we have in triangle law of addition, right? It's not possible to do that. Okay, so this is the procedure. Now, once again, if you would go back and realize what was the whole thing about displacement, you would, I'm sure, understand this better. Let's say a person starts from this point A, right? So this is the initial position vector, and then the person roams about here and there. Okay, finally stops, right? Oh, sorry, arrows like this. Okay, so this is the final position vector. And so now if I want to find delta R vector, it should be R2 vector minus R1 vector, right? It should be r2 vector minus r1 vector. So as we have discussed, right, as we have discussed, this vector will definitely be from a point to b point, right? That is like this. So this is r2 vector minus r1 vector. I hope you are not at all surprised by this diagram now, right? Kavya, it does not matter where vector A or vector B are. Okay. So because you are having this question, I think many more people might have the same doubt or same question regarding this. So let me just try one more example. Okay. Let me ask you, what have I drawn? Everybody, pay attention. You have to tell me, the vector that I am drawing. What name, what symbol would you give to it? Okay. What's this vector? What is this vector? Come on. So we definitely have a split, right? Some of you are saying this, some of you are saying the other way. So a lot of people are going to get it wrong. Ria, there is no A and B here. There's no A and B. Dikshita, there's no R2, there's no R1. Come on, what are you doing? Look at the diagram carefully. There's no R2, R1, right? Ananya, there's no vector. Okay, this is D, right? This is not O. Bad handwriting, I'm so sorry. All right, let me write it there. The correct answer is, this is vector D minus vector C. This is the correct answer. Right? This is the vector D minus vector C. Right? Again, look at this. We have drawn them by common tail, right? From same point. So this is definitely going to be subtraction. So we have possibility, right? C minus D ke D minus C, right? But look at this. Where's this head of this vector? Here. And the tail of this vector is here, right? So this is definitely D vector minus C vector, right? Not this. This one. Clear? All right. So what I mean to say is, you don't have to worry where is which vector. You just have to follow the procedure, and every time it will give you this proper result. Okay. That's why I've made you write these steps clearly, so that you will never be confused, right? Okay. So what was that sentence which I was going to say about all this? See, everyone, please realize that all our mathematics, all the maths that you see in this world has arisen from nature. That is, when we observe nature, we tend to see some patterns, some rules that nature has made. We tend to see some rules or patterns that nature has made. So the same thing happens here, right? The same thing happens with addition. Okay, Preet, I'll answer your question. Let me just finish what I'm saying, right? So here, why do we have a triangle law like this for subtraction? આવો જ law બનાવવાનો કોણે કીધું? See, there's one difference between laws of physics and laws mentioned in constitution, okay, or laws that Supreme Court will make everybody follow, right? These laws, we have not made them. See, you might have a doubt. Have we made these laws? No, we have not made these laws. Okay. Has Newton made laws of motion? No, wrong. No, incorrect. Newton did not make laws of motion. Okay, right? Newton is not like those many people who wrote Indian Constitution, right? The great people who wrote Indian Constitution. Newton is not such a person, right? Delivered, that's also wrong, Vedant. The correct way to say it is Newton merely discovered, right? By observing things, Newton merely or only discovered it, and he wrote it as a sentence that he is observing so and so things. That's it, right? That's it. That's what he observed. Okay, that's right, Falak. Exactly. Yes, Rehan Khan, this is applicable in all cases, right? So you should understand that some people, some students ask me, sir, what if we don't follow physics laws? અરે તમારી તેવડ જ નથી. ફિઝિક્સના લોઝ ફોલો કરવા જ પડે કારણ કે નેચરે બનાવ્યા છે. યસ, કોન્સ્ટિટ્યુશન વાળા લોઝ ફોલો ન કરો તો તમને પનિશમેન્ટ આપી શકે, પણ નેચરના લોઝ ફોલો કરો નહીં એવું પોસિબલ જ નથી. If you don't follow, see, that's actually at the heart of science. Suppose someone finds or someone is able, okay, someone is able to violate law of nature. Suppose someone is able to violate a law of nature. That means our understanding of nature is wrong. That means our understanding of nature is wrong. No, Falak, you are wrong. Law follow કર્યા વગર ફિઝિક્સમાં કંઈ ન થાય, that's wrong. Law follow કર્યા વગર possible જ નથી. Nature itself works on these laws. Okay, so even if you move your hand, you are following the law. Nothing has the power to go against the true laws. But like I've said, nobody knows which laws are true. It's just that we study nature, we keep on studying nature, we try to understand how nature works, and we find out these laws. કાલે કોકને ખબર પડી કે આ law બરાબર નથી ચાલતો and I can violate that law, so we will not kill that person, we will not give punishment to that person, rather we will say, okay, this law is not good, change the law. Okay, it means our understanding will improve. Right, now the question that Preet was asking. Yes, correct, Vedant. The question that Preet was asking, right? How do we know whether we have to draw a vector minus b vector or b vector minus a vector? It will depend on situation. For example, suppose you talk about this person moving from, Preet, I hope you are there, otherwise you will miss it and others will take the learning from your question. So suppose a person was here, this person moves here and there and goes over there. So in this position, I want to find this vector, correct? I don't want to find this. I hope you realize that finding this is useless, right? Correct, Preet? I hope you realize finding this is useless, because if you want to find displacement, we should find this. Correct? So I hope now you have understood how will we know whether we have to find this or this. It depends on situation, right? It will depend on situation. જેવી situation આપણે એવી રીતે find કરી લેશું, right? આપણને બે રીતે આવડવું જોઈએ, that's it. Okay. Right? So I think that's enough for today. See you all tomorrow. Goodbye, everyone. Goodbye.